Okay, so this is Warp Driver. This is a physics of golf game. The setting for the game is, it takes place 500 years in the future, where humans get bored golfing on just Earth-like golf courses, and so with their technology they use it to take it deep into space and use robot avatars, which they are controlling, that then will be able to golf in conditions that are not suitable for humans to actually golf on. So you get this really dynamic experience between varying conditions and very challenging courses that you're going to come across. Okay, so from the interface, one of the neat features that we have in this game is something called the glossary, and it serves as sort of a database for everything that the students will see as they progress through the game. It's a good reference point for facilitation because you can always refer kids back to the glossary, and it has certain physics terms that align very well to with what's in the game but may not be completely addressed. And so this is sort of the hub for everything that would necessarily need a definition as you play through the game. So it's a great resource for facilitators as well as curious kids that may want to clarify certain points. So the first one that we're looking at is acceleration's y component, and we actually look at velocity's y component, and since we're dealing with vectors which are component vectors, and actually usually the vectors that you see that are just single vectors are going to be the resultant vector, and they can each be broken apart into component vectors. This is something that goes into vector calculus and just general vector notation. And so this is sort of a clarifying statement as to what the y component is signifying for acceleration. And this is important too for acceleration because on the first planet, it's always going to be pointed down. Now, one thing to note as far as a facilitation standpoint is that the direction or the value, whether it's negative or positive for a vector, is dictating direction and not simply a numeric value that's negative. One of the other things addressed, we could just pick conservation of energy. This is a large underlying factor throughout the entire game. And a big component of physics. And so we talk about energy as always being transferred. We never show it being created since it can't. And this is sort of what law of conservation of energy speaks to, is that it can't be created or destroyed. It's only changing its form or transitioning through different states. And then you can also get into some of the golf facts about what the dimples are doing. Displacement and distance is a misconception that students may have, and this is a good clarifying statement to the difference between the two. Okay, so first I'm going to create my character. I will name him Test Character. Okay, so we can choose between male or female models. Here you can see, and then you can alter the color scheme. I prefer the white, which looks interesting. Okay, so we're going to start out on the driving range. This is to serve as a warm-up to the game, get you used to the interface, also the basic controls of the game, as well as to scaffold a number of the physics concepts. And you'll notice that there's loading screens that also touch on some of the other physics concepts that weren't really fit into the game, but they play well with what you're about to experience. So in my driving range, you have no gravity and you have no atmosphere. So we don't have any forces acting on the ball after I hit it. So I'm just going to go through this tutorial so that I can progress and I can actually show you some of the actual experience of the driving range. So it's telling me to pull back and just hit it. And this is the general swinging mechanic through the game. You're trying to hit these little bots that are sort of floating out there as your targets. The interesting thing about this driving range is that, and actually it fits with the whole structure of the physics in the game, is that it allows us to scaffold up the concepts quite well. And you'll notice that as the levels progress and the planets progress, we're going to sort of layer on top of the previous concepts with new forces and new acting conditions where you're going to have to hit the ball. So right here in this planet, or this driving range, what we're looking at is that we have no forces after you hit the ball. Actually, the only force is the instantaneous force of when you impact the ball. And after that, all you have is velocity describing the direction and motion of the ball. And if I were to miss, you'll notice that this is something called Newton's first law. And actually, in the driving range, there is no call to the type of physics concepts that are happening. A lot of it is just going to be observational, and this is sort of where the facilitation guides will fit in. Because with this game, if we bogged it down with too many tutorials, it would have broken away from the fluid nature of the gameplay for golf. So in this first level, we have Newton's first and third law. Newton's first law is inertia, which means a body at rest will stay at rest unless acted upon by a force. Right there, that impact. And a body in motion will stay in motion unless it is acted upon by an opposing force. So if I miss one of these little Iguanobots, that ball will just carry on infinitely until it runs into a planet or a celestial body. So this is a nice prep for what we're going to get into, which is primarily Newtonian physics, which is going to be layered in throughout the rest of the game. And so this actual driving range, as much as it's serving as a tutorial for gameplay, which is what you're going to see on the next planets after this, it's also serving as a good platform for teachers to do a deeper dive into some of the observational physics that are learned here. It's a good platform to sort of say, all right, play through this driving range, and then tell me what you notice. And a lot of this is going to be supplemental for physics classes at the high school level.